Okay, so about 2 weeks ago, I posted on the Obduction group and I asked if people would like me to make a video explaining the way that computer hardware works as far as you need to know to play Obduction. So originally, when Abduction first came out, there was a lot of people on the Abduction fan page on Facebook, especially, asking why it wasn't working, how it wasn't working on their computer. And the first thing to recognize for this is Cyan's game Abduction um, is incredibly graphics intensive. It's probably one of the more graphics intensive games that actually came out of the whole of last year, including games like The Witcher and stuff like that. And there's a few reasons why that is. We'll go over a few of them. But the one thing to know about this is if you know much about computer hardware already, this probably isn't going to be very useful for you. And also, I simplify things a lot more than they actually are in practice. But this is just to make sure that people have an idea of what they should be getting, what the problem might be in their computer, and how they can get themselves set up for abduction. So, to start off with, I made a nice boring, unfortunately, flowchart thing. Okay, so this is what we're going to refer to during the video to make sure we always are set. Now, when you're looking at a computer and you're building a computer or whatever, or you're looking at specs on the internet, a lot of it can just seem like complete gobbledygook. You don't really know what any of it means. But what I wanted to do is walk you through briefly how a computer works and how your game is shown on the screen and how you can play it. I'm not going to go into sound because most people's onboard sound is going to be fine and all that sort of stuff, so don't worry about sound. We're just going to go through the things that make the graphics run smoothly and load quickly so you can play it. Now, what I wanted to show you is really, in a computer, as far as graphics are concerned, there's only five parts that you really want to worry about, and one of them you don't really need to worry about at all. Firstly, you have the motherboard here, and the motherboard's that big. Let's quickly find you one. It's that big board at the bottom. It looks something like one of these. These are weird and wonderful types. It's a newish kind of one. They look like that, and effectively, that's just the thing that things plug into, and that's all you need to worry about for that. So it's got some PCI slots, some DIMM slots for RAM. It's got a processor slot here. It's got like onboard sound and stuff going out there, and the networking and all that sort of stuff goes around there. Some stuff in here. So don't worry about all that stuff. But here's where the graphics cards would go. Here's where the RAM would go. Here's where the processor goes, and that's all you need to know. And underneath, there's lots and lots of channels where these can all talk to each other. That's all a motherboard does, really. It just enables all of the other stuff to talk to each other. Obviously, Puritans will tell me that it does so much more than that, but really, for our intents and purposes, that's all it does. So that's all you need to worry about. Going back to our here, so that's what this motherboard does. Also, the CPU plugs in. So these lines here are showing that they're just connected into the motherboard and they talk to each other. But that's all we're going to talk about as far as motherboard's concerned. If you use PC Part Picker, which is a great website, here we go. If you go on PC Part Picker, and you can start a system build. If you're going to do this, you can put in a CPU first, and then that dictates what the motherboard is, because it's got to have the right hole for the CPU to go in. So once you've chosen your CPU, if you are going to do that, it's linked to the motherboard. The motherboard has to fit the same CPU, but everything else pretty much is you can change. So then we're going back to this here. So these little boxes here, these are files on the hard drive. I've a little description of that. What we're trying to do in our games is we're trying to get the files off the hard drive where they're stored, and everybody knows what a hard drive looks like. It's one of the little spinning disk things that go inside the computer. We're trying to get that into graphics on the monitor here. Now, the thing is that it's not quite as simple as just them just appearing on the monitor. I can't just grab one and just put it on the monitor like that. It doesn't work like that. They've got to be processed, okay, by the GPU here, which is in the graphics card. So in a normal computer, the way it works is hard drive has a lot of storage, but is normally quite slow. And we'll go into that in a bit later about how to get that faster. And what happens is the CPU that controls how these things work, just tells them how to do it, will transfer the files from the hard drive into memory. It's called RAM. You'll see it called RAM all over the place, which stands for random access memory, but you don't need to know what that means. So it transfers the files from the hard drive to the RAM, which is smaller but much faster than a hard drive, and then when it's needed, it will be pulled from the RAM and put into the graphics RAM, which is a similar concept, just temporary storage, and then that will be sent when it needs to be on the screen to the GPU, that will then process it to turn it into graphics that will put it onto your screen. That's effectively how the whole thing works. So the GPU needs to process a file for it to go on the screen, and to do that it needs to be in the graphics RAM, otherwise it can't access it, and then before it gets into graphics RAM it needs to be in something a little bit faster than a hard drive. Okay, so, and this is how loading screens work. So if you have a game with a loading screen, what's happening is it's loading, taking all these files off the hard drive like this, putting them into the RAM like that. So then when they're needed, they can be pulled into the graphics RAM like so, and then the GPU can pull them out and put them on the monitor. So there's all these white boxes in the middle here, except the GPU. These three white boxes here all have capacity. So because we're trying to get all these files onto the screen, we need somewhere for them to be stored. So hard drives and SSDs, so HDDs, which is a hard drive, and an SSD, which is a solid state drive. I'll explain the difference between those. They have a large capacity, so they can store your operating system and all of your games and everything like that. All of the files that are needed to run a computer, that you can store on those. RAM, because it's so much faster than the way it works, we won't go into how it works, but it's a much smaller capacity. So my computer right now has 16 gigabytes of RAM. I recently upgraded it from 8. 8 is probably okay, but for Obduction you probably want to go as 16 plus. I would recommend, having done my own testing on the game. And that is fast, no moving parts. Memory has no moving parts in it, which is important, whereas a normal hard drive would. Has a spinning disc with a little needle like a vinyl record player. And in the RAM there's no moving parts, which enables it to very quickly send those electrons through the cables in the motherboard and all that into the graphics card. Now I've put these little purple boxes here on these red arrows showing showing where these speeds are. So you've got 3 different speeds you need to worry about. Actually 4. I didn't put one here. So, and these are the speed at which your computer can move these files around. Okay, so the first one is what's called a read-write speed, and that's how fast you can read or write to your hard drive. So reading this direction, we want read speed is the thing we want. We're not really writing things back to the hard drive, well we are, but let's forget that. We're mainly reading things off the hard drive to send the files over here. So the read-write speed is really important. Now, a basic hard drive, and I should get a picture on these up. A basic hard drive looks, well, there's loads of random stuff here. Should have got this up in advance. Yeah, basic hard drive looks like one of these. This is what a hard drive looks like, and you can see the innards on some of these here. It's a little disc. It's actually multiple layers of discs, but a disc here with a needle that goes around it and reads the disc. Now that's fine for most things, and these are the cheapest option. However, for something like Obduction, you really want to go for what's called a solid state drive, which is effectively, if you've ever seen a USB stick, a very big USB stick. We won't go into too much detail about that, but it's just a very big USB stick, no moving parts. So here's the difference. Here's a hard drive, here's a solid state drive. No moving parts in a solid state drive, which means the computer can read it all much, much faster. Like, a lot faster, so much faster. It's you know, orders of magnitude faster. Now, so in a perfect world, we want an SSD for Obduction, and I'll explain why that is now. A lot of games will use big long loading screens and a big long loading screen will load all of these files that they need for the next level in a game into the RAM. And that's what the loading screen, most of what the loading screen does is it's reading all this data in the hard drive and moving it over to the RAM. And the RAM is obviously much faster, so then it can just be pulled into graphics RAM when it comes onto your screen and sent back again. It goes both backwards and forwards. Now, in Obduction, it does do that on a loading screen, but it also does what's called I think they call it something like from hard drive streaming. Effectively, what it is as you're going through the level, as you go to different locations, whilst it's loaded, say this much of it on the loading screen when you change areas, actually sometimes you get to a new area and it pulls some more just for that area, and then sends it back, and then pulls some more for a different area. So it streams. It's called streaming, doing it on the fly, off the hard drive. Now, because of this arrow here, this read-write speed, we want this, because it's doing this all the time, we want it to be as fast as possible. And that requires changing from a hard disk drive, which is an HDD, to a SSD, which is a solid state drive. And that is the #1 recommendation I'd make for the start of this video is, if you can get an SSD to play Obduction off, it makes a humongous difference to this game, more than nearly any other game I've played over the last couple of years. SSD's huge because this read-write speed goes through the roof. So we've sped this process up here, and that really helps. Now the next speed we have here, this is probably the least important one, because it's already pretty fast. You'll see this on RAM. You'll see RAM is in megahertz. So if we go on the website here, like scan, let's just go to memory. Who cares what memory it is? What memory stick? Okay, I probably should have got all this up before they've changed their website. Storage, PC, laptops, components. Here we go. Memory. Okay, so you see all of this memory here. Don't worry too much about that. The only thing that you need to worry about is either DDR3 or DDR4. The motherboard chooses that. If you've got DDR3, it's because your motherboard has DDR3, and DDR4 is because your motherboard uses DDR4. Okay, that's what you need to worry about. And then you'll see all these different megahertz, okay, on all this different RAM. All that refers to is the speed of this arrow here. The speed of this arrow here. Okay, the faster it is, the faster it can move these boxes over into the graphics RAM here. That's all you need to worry about as far as it actually goes backwards and forwards, but let's just assume forwards for now. Now, as long as if you see the way this works, you'll realize why you need an amount of RAM. The more your computer can put into this RAM, the less it's having to pull off the hard drive over here. So if you can load loads into the RAM, it's not having to keep on going back to the SSD and pulling more data off it. It's just all sitting there. They can load more than it needs to, and Bob's your uncle. So the more RAM you have, the more of these little boxes it can store at one time, meaning the less it has to get rid of and pull a new one in from the SSD and get rid of another one and put it back again, and then pull another one in, and the more space it's got here, it can just fill itself full of all the memory that it needs to use before it goes to the graphics card. Okay, so we want fast read-write speed to go to the RAM, which needs a whatever speed you can get, really. Don't worry too much. 1600 megahertz will probably be fine. I've got a 2100, and I think it's 2103. I think I've got 2133. That's the one. 2133. I've got 2133 DDR3 actually, and DDR4 is the newest one. It's just a better architecture, but don't worry too much about that. So with that, we'll move on to what the most important part is in this whole thing, which is the graphics card. Now, this is a very simplified version of what happens in a graphics card, but all its job really is to do is to take these files that it's received from the RAM, put them into the GPU, and well, the GPU looks at them and goes, "This is how I turn this into a file," and sends that through your HDMI cable or your DisplayPort, your DVI cable to the monitor, and it shows on the screen. And it'll store some stuff in the graphics RAM, and it will keep on pulling it into the monitor, keep on pulling it in and out. Because if you see one tree now and then you turn around the corner and it's got the same texture on the tree, which is just the colours that you'll see on a tree. And that's one thing to say. A lot of this is textures. A lot of this is pictures, 2D pictures that are mapped onto 3D wireframe models, like the leaves of a tree to make the leaves of the tree green. That's all a texture is, really. It's actually more than that, but for our intended purposes, that's what it is. So this GPU needs enough graphics RAM which is faster for these purposes than normal RAM. It needs enough graphics RAM to store as much as possible, so it's not having to keep on pulling it backwards and forwards from the RAM, because each one of these arrows is faster as we go down the chain. This arrow here is much faster than this arrow, but this arrow here in the graphics card itself is much faster than this arrow from the RAM. So we want as much graphics RAM as possible. Now, for Obduction, it has a lot of high resolution textures, which means it fills up RAM very quickly. So we want to be using the best graphics card we can. Now, what I did is I went on to Tom's Hardware, which is a great website, and they've got a list of desktop GPUs. Okay, these are desktop GPUs. If you see an M anywhere in the number for your GPU, don't worry about all of these things yet, but if you see an M anywhere, that's a mobile GPU. Okay, now mobile GPUs are considered mobile because either they're smaller, which means they have less space for extra RAM, or they are smaller and they have less capacity for cooling, because all these components get hot, and the cooler they run, the faster they can run without what's called thermal throttling, which is where they stop themselves from running so fast to cool themselves down so they don't get damaged. So mobile ones, they'll normally run at slower speeds so they don't heat up so much. They're normally smaller, they don't have as much space for extra graphics RAM, and they've got other things that they're also, there's lots of other reasons why. If you have the option, you want a desktop GPU. Now, I'm not going to go through every single GPU you possibly can get because there's so many, but really there are two companies that make the actual diamond bit here, which is a GPU, and then there's lots of companies that make the whole green bit. So the whole graphics card is made by lots of different companies. I'd recommend EVGA. They're very, very good. And you've got also Asus. They're okay. Gigabyte, probably okay. MSI are probably the other one. So MSI and EVGA are my two personal favourites, but there's lots of people who probably will say, "Oh, you've forgotten this one," but don't worry too much about that. So now, GPU will either be made by AMD, who make the... Sorry, I'm an idiot. ATI. AMD make CPUs. ATI, which make the Radeon GPUs, which is just this diamond here. And NVIDIA, which make the GeForce GPUs. At the moment, if I was to make a recommendation for this particular game, I would absolutely say go with an NVIDIA GPU. I'm not a fanboy, I'm not trying to just say NVIDIA are better. At the moment, I would really go with an NVIDIA GPU. There's two reasons for that. Number one, most game developers who make games develop their games on NVIDIA GPUs. So bugs are normally found to be much more prevalent in the ATI Radeon GPUs, because the game developers didn't notice them when they were making them, because they're making it on an NVIDIA GPU. There's obviously exceptions to that rule, but that's the number one reason that I recommend people to go to NVIDIA GPUs. If you're going to have issues, it's more likely to be on a ATI Radeon GPU. CPUs, at the moment, there's absolutely no discussion about it. You get it at Intel. You get an Intel CPU. There's possibly new AMD ones coming out later this year, which might be good, whatever. Right now, at this moment, you want an Intel CPU. You want they come in three varieties that you need to worry about: i3, i5, and i7. And then the higher the number after that, so if you had, say, a 6800K, okay, the higher that number is, the more recent it is. If it's in the thousands column. Let's go on here and have a look for CPUs. So you've got here, you've got these are actually based on socket types. Here they've got they're called Haswell, Kaby Lake, Skylake, Broadwell, all this sorts of stuff. Those are just the generations of the CPU. Don't worry too much about it. If you can get yourself an Intel Core i7, the higher this number here, ignore most of this stuff. The higher this number here is, the better. But it doesn't really matter a huge amount. You just want for Obduction, I'd say an i5 or an i7. And the newer the better. But processor isn't going to be. It's not going to be the be-all end-all for you in Obduction. As long as it's modern, it's not 15-year-old Q6600 or something like that from a million years ago. As long as it's an Intel Core i5 or an i7, I would pretty much guarantee you're going to be fine. On the Obduction specs itself here, it shows CPU Intel i5 2500 or equivalent. This is probably better here, 4590, which is actually so this 4 here, that's the 4th generation i5. We're now they've just brought out the 7th generation, so anything higher than a 4th generation i5 would be fine. There's 7700s here and 6950s. Some of these are very, very expensive. Don't spend £1,700 on a i7, please. I do not recommend that. Just get yourself something that's decent that will last you a few years. So that's what the CPU does anyway. But going back to the graphics cards, here is an example of a graphics card. This is an NVIDIA GeForce made by EVGA. So EVGA made the green bit, which includes the GPU, and the NVIDIA GeForce bit is the diamond here. This GTX 1080 is the version, that's the most recent NVIDIA graphics card. That's the top of the line one, except the very, very expensive one called the Titan that you don't need to worry about. This is the top of the line one. If you've got the money, I'd say get one of these. Not necessarily this one; it's quite expensive. But EVGA are my favourite personally, but that's up to you. And Founders Edition, you don't need to get Founders Edition. Those are just get a normal one. GTX 1080, so that's the version of that diamond, which is the best thing. Then 8 gigabytes. And that just means it's an 8 gigabyte card, which means that you can see here 8 gigabytes of GDDR5, which is the type of RAM. Okay, so that when you see these gigabytes in a graphics card title, that's referring to how big this box is here, and how much of this it can store at one time before it needs to get rid of it and pull new stuff in because it's run out of space. Okay, so that we're getting to an idea here of how this whole thing works. We'll go into my perfect world situation for Obduction. You have an SSD with a high read-write speed. So if I go to storage and go find some internal. Don't worry too much about all of this, but let's do a SATA 3 SSD. So something like this, a 6 gigabyte per second. You're looking for this read. That's the speed of the SATA 3 connection. Then this is its read-write speed. Okay, 540 megabytes per second, write 430 megabytes per second. That's the number you want. Everything else is a little bit. Don't worry too much about that. You just want this read-write speed here. So a high read-write speed SSD into some decent size of RAM. I'd go for 16 gigabytes of RAM for Obduction. Speed, don't worry too much about it. Whatever you can get, the highest you can get. It does. Speed actually for RAM very rarely affects price. You just have to have the one that fits the CPU here. This little circle here. You need to make sure that your processor can do it. And if you're worried about whether your processor can do it, use PC Part Picker. I can put in any CPU I want. There we go. Add that in. And then I can go to memory and put in, I don't know, let's put in that in, see if it works. And no incompatibilities found. But if I was to go and get myself, if I was to get rid of that and choose, let's find a DDR3 and then put it in a DDR4 motherboard maybe. I don't know. Pretty much, if you I keep on making computers that work when I'm trying to make them that don't work. But effectively on this, it'll tell you if it doesn't work. So before you buy anything, even if you don't use this to design a computer, or even if you're just buying something new to upgrade your computer, use PCPartPicker.com. It is really, really good, and it will let you know if you've made any mistakes. Okay, that's really, really useful tool. Probably one of the best ones on the internet. So we've got our SSD going to our RAM, which fits our CPU and fits in our motherboard, and we've used PC Part Picker and we've made sure it all fits, and we're not gonna buy a £200 worth of stuff and it doesn't work. Then we send it to our graphics card, and you just want the best graphics card you can get. There's nothing more complicated than that. It's the best graphics card you can get, and you can use Tom's Hardware's GPU hierarchy. Maybe here we've got the Titan X Pascal, which is a £1,200 graphics card. Then we've got the three main ones that you need to worry about at the moment: the 1080, 1070, and 1060. The GTX 1080, 1070, 1060. I have a 6GB GTX 1060 by EVGA that I got about a month ago. Runs Obduction absolutely fine. If you're looking to save money, GTX 1060 by EVGA. Let's see if they've got one on the internet. EVGA 1060. Here's the one. So this is the one I got. It's a short little stubbly thing. It's $259. I got it for about 240 quid in pounds. Brexit. And they and this was absolutely fine. It looks like that. It's got this one here, I mean, it comes with a 3GB and a 6GB version. You want the 6GB version, it's much better. It's got 6GB of this box here. It's got a 1060 GPU, which is just a different, it's the 10 series, which is the most recent one. And then it goes to monitor. If you're not worrying about budget, get a 1070 or a 1080, and with 8GB of graphics RAM. And that's my recommendation for how you build that. Now, if you have problems running Obduction, it will be because to have this. It still has the same technology underpinning the way the game works, and it still has to pull these files out of the SSD. It still has to put them into the graphics RAM. There is a lot of very complicated graphic stuff going on in Obduction that requires quite high power components, and that's why there's recommended specs here which are quite high. This is I don't know if I'd recommend you try and play it on minimum. The recommended spec here is absolutely where I'd start going for. GTX 970 is an old card now. I'd just get the 1070 or a 1060, which would be better than that. Off the top of my head, I can't think of anything else I wanted to go through right now, except the fact that I hope you send me messages so I can answer any more questions. If there's anything, a big topic I've forgotten, I'll make another video, so you've got that. And I hope this hasn't been going on for too long. I hope you understood everything I was saying, and I will see you in Obduction.